The purpose of this lesson is to develop a strategy when we can't factor or move the constant to the other side of an equation and take a root. We need more strategies, and this one, kind of like the quadratic formula, will work for any polynomial. You just have to learn the strategy. Here's the agenda. Today we're going to divide polynomials using long division and then using synthetic division, which will help us figure out what are the x-intercepts of a polynomial, or what are the factors of a polynomial if it's factorable. Let's go to examples. We're going to use long division to divide polynomial x cubed plus 2x squared minus 6x minus 9 by x minus 2. And then what we're dividing by is called the divisor. So when you hear me say these words, this is what I'm referring to. Divisor goes outside, and the dividend goes inside. I got to figure out x times what could get me close to x cubed. So x times what gets us close to x cubed? X squared. And I write it above the x squared term. So I'm going to take x minus 2 and multiply it by x squared. I'm going to have to do a little distribution. I'm going to have to take each of these pieces and multiply it. So we get x cubed minus 2x squared. There's a typo in the dividend. It was supposed to be a plus 2x squared. Okay, so now after you multiply divisor times what you wrote down, you have to subtract this term. When we subtract, both signs get changed. And then we combine them. X cubed minus x cubed. X cubed term goes away. But now I've got this x squared term. I've got 4x squared. And just like in the long division process, once I get done or get to a stopping point, I have to bring down the next term and repeat the process, asking myself, okay, x times what could get me to 4x squared? 4x times x will get me to that 4x squared. So now I'm to the process of distributing and writing the product below. X times 4x and then negative 2 times the 4x, because you have to make sure you distribute. And I've got to realize, wait a second, I need to subtract this product. So I'm going to change my signs. After combining, I'm going to bring down the next term. And repeat the process. X times what could get me to 2x? Once I realize it's a 2, now I got to distribute that 2. 2 times this binomial, distribute it, we get 2x and then minus 4, and I write it below. I realize, wait a second, I need to subtract these. So I'm going to change their signs. And I'm left with a constant of negative 5. To write a remainder, we're going to have, okay, remainder is negative 5. So I'm going to, negative 5. I could either add negative 5, or I could put a minus here and then have a regular 5. But it's going to be a fraction, the remainder over the divisor, x minus 2. So we just did long division. And the whole answer, the whole quotient, is x squared plus 4x plus 2 plus negative 5 over x minus 2. That's the quotient. When I get a remainder, that means, wait a second, this isn't perfect. This isn't a factor. When you don't get a remainder, then that means it was supposed to be factorable. Or this should have been a factor. Let's try it again. first step is to figure out what can I multiply x by to get close to this little binomial. Notice how I have a binomial in the divisor. So what would get me close to that? X times what could get me close to x cubed? I write it above the squared term just to keep organized. I'm going to take that x squared and distribute it throughout that binomial. This gets me x cubed plus 3x squared. But I need to recognize that, wait a second, I need to change these signs. So, change both signs. So I get negative 1x squared, and I'm ready to bring down the next term. I ask myself, x times what? Gets me negative x squared. So I'm now going to distribute, getting me negative x squared minus 3x. But at this point, I'm going to change the signs. And I bring down my next term. I again ask myself, x times what could get me to negative 3x? And then I multiply by the divisor, taking negative 3 times this piece and writing it below. So we get negative 3x minus 9. But I need to realize I have to subtract that. So I'm going to change those signs. The x terms wipe out. Wait a second, and so do the constants. X squared minus x minus 3 without a remainder. And I want to talk about how this is important. When you take something, or when you have a divisor, or a dividend divided by a divisor, and you get no remainder, that means this dividend was factorable by x plus 3. And the other factor is x squared minus x minus 3. Using this strategy, we can figure out, wait a second. So I could have had x plus 2 sets of parentheses. One of the sets of parentheses would have been x plus 3. The other set of parentheses is x squared minus x minus 3. And couldn't I take this a step further using multiply, add? Sure can. My bad. Nothing multiplies to negative 3, adds to negative 1. So this would have given my only x-intercept at negative 3. My bad. I feel like I'm jumping ahead. This would have given an x-intercept of negative 3. And then we wouldn't have had another one here. We're going to go back through the previous two examples and see how synthetic division can work. When we synthetically divide, we're going to put a little box in a corner, and I say box. It's like a backwards L that's going to hold a number here. So there's a box in a corner that's going to hold a number. And then there's going to be a line of numbers and a second line of numbers. And then I'm going to have this line here, and there will be a third set of numbers. So what synthetic division actually takes up is 3 lines. 3 lines on your notebook paper. First line is going to hold the box. The second line, the bottom of the second line, should have a solid piece. And the third blank line will have your answers. So just the coefficients of the dividend will start be lining up after the box. Not only that, but it's got to be the coefficients of the entire dividend. We've seen polynomials where it's missing terms. Like, what if this x squared term was missing and it just said x cubed minus 6x? We would have to put in a placeholder of 0 in the x squared spot. So the only way synthetic division works is as long as, okay, if you start at x cubed, then you better have x squared, x to the first power, x to no power, going after that. Coefficients of the dividend line up. So the boxed number will be the 0 of the divisor. Wait a second. 0 of the divisor. This is your divisor. What would make this 0? That's what that's talking about. 0 of the divisor is what would make this 0. A positive 2. If you put in a positive 2, that would make this 0. So the 0 of the divisor is a positive 2. That number will go there. And then we'll talk about how we get these other numbers. Let's start putting in the coefficients, and the 0, the divisor. And then we're going to have the coefficients lined up. So the coefficient of the cube term will be first. That coefficient, the leading coefficient's 1, then a 2, then a -6, then a -9. Here's the rules of synthetic division. And you're not going to understand it the first time, you won't understand it the second time, but hopefully by the third example you get it. First step is you bring down your first coefficient. So, I bring down the first leading coefficient. There's a rhythm to this strategy. Multiply, add. Multiply, add. Multiply, add. And here's how it goes. You're going to take the numbers down here. You're going to multiply it by the number in the box. You will write it below the next term, and then add. So let's go through this. You're going to take 1 times the number in the box, and you're going to write it down in the next column below the next term. So we get 4 in this column. I got a new number down here, so I'm going to multiply by that number in the box and write it below the next term. And then add. Notice how I just multiplied? Now I'm going to add. So adding -6 and 8, I get a 2. I get a new number down here. So I'm going to multiply, then add. Take 2 times the number here, write it below the next term, and add. So when we synthetically divide, these new numbers give you the coefficients to your quotient. But the very last number is going to be your remainder. So the very last spot is your remainder spot. Now, notice how we drop down to x squared. That's going to be another rule of synthetic division. Whatever we start out with. We started out with x cubed. When you take something cubic and you divide it by x, you're left with x squared. The degree will always decrease by 1 when you synthetically divide. Now that we've seen kind of how it works, we're going to do it again using synthetic division. We typically have to identify where the divisor is. So, we know this is the divisor. And our setup will have a box and then a line in the second blank. But the box number is the 0 of the divisor. So what would make this divisor 0? The -3 goes in the box, and then we line up coefficients as long as it's in standard form. So we got to make sure it's x cubed, then x squared, then x, then no x. You have to bring down that first coefficient to start. And then you start the multiply, add, multiply, add, multiply, add. So I'm going to take this number down here, multiply it, and write it in the next column. So 1 times -3, that product is written here. And then I add 2 and -3. So I just multiplied and add. I'm going to multiply again and write that product over here. So -1 times -3, product goes here. And then I add vertically. I multiply -3 times -3 and write the product here. And then I add. So because we started out with an x cubed term, when I divide by x, I'm going to be left with an x squared term. So we're going to have 1x squared, and then it decreases in order. Minus 1x minus 3 plus 0 over the divisor. But wait, when we have nothing as the remainder, we're just going to leave that off. So our quotient is x squared minus x minus 3.